Now we'll talk about writing into cache. Okay, so far we have not seriously taken these writes in cache, but they are not so easy. They are little bit complicated and they are different from reads. Okay, we will see the differences between reading the cache and writing the cache. Okay, now example, let's say you have a processor and this is the scenario, either because of instruction fetching, otherwise operand access which is in main memory, we generally wants to go to main memory, correct? Two reasons. So whatever may be the reason, when you wants to go to main memory, for that we have already main memory address. Okay, you have a main memory address and you want to go to that main memory, but data is sometimes in the cache. That's why always your processors will be designed such a way that this main memory address will be taken and the appropriate block will be identified. That means which main memory, we know the process, right? Based on direct map technique, otherwise associative, based on that, using this main memory, we finally come to the cache, right? That is nothing but looking into the cache. Assume that let's say you're reading the data, okay, which is specified by this main memory address. Then for that, this processor will have a hardware such a way that automatically will come to the right block. Okay, let's say this is the block currently relates this main memory address. On that, let's say we have to read this particular word. Okay, there will be word offset. Using that, we will read it. That's it. Very easy, right? But you don't really require to update anything in main memory. We never touch main memory if the cache gets hit, right? But if you miss in the cache, then what are you going to do? When there is a miss when you are reading, then immediately we will go to the main memory and we access the corresponding word, right? Before that, before accessing it, generally the scenario will be, however, all these main memory block will be transferred here, which is the right one. Okay, example, this is a block which you are referring, then that block will be copied here, then after that the appropriate word will be taken. Understand? So and one more thing, so there are a lot of different ways people can do. That means depends on the architecture. So many different ways we can do the things. Understand? Maybe I can first read the memory word, desired thing, then later I can move the block. Anything is possible, right? Don't worry about them. That's why I don't want to go into that details first. So what I would like to say is, finally what happens is, all your main memory block which you are referring will be transferred to the cache. You remember this, forget enough. Then after that, we read again this cache block, and especially we will read our desired word, right? This is about reading. So reading is done. When you get hit, what happens? When you get miss, what happens? We have seen. Now we will see writes explicitly. So writing is a big story. First of all, we start with write through procedure. What is write through? I will tell you. First of all, whenever you are writing, the example instruction is store instruction. Because of store instruction, we write something into the main memory, right? So this is a main memory address. And first, using this main memory address, we will come to the cache. We know how to convert this main memory to appropriate cache block, and we will come to cache block and we will check, right? And we'll check the tag fields, everything, right? So after that, let's say finally you realize that there is a hit. Whenever there is a cache hit, that means your data is available in the cache. Then you write appropriate word. I will show clearly. So this is your cache. Let's say I am showing in a bigger way so that easily we can understand. This is the word, let's say you want to write. Okay, this is the word which you want to update, right? That is what write, correct? So this is the position. For that, because it's hit, you get it and you will come to here and will update it. Okay, so you updated it finally. That is about hitting, right? But the problem is, generally when you just update in your cache but not in main memory, we have the corresponding word here also, right? Example, this is word number 1. Then in some main memory block we have the data, right? Because we know that we follow inclusion property. That means whatever you keep in the cache, that must be present in main memory, right? Such a way we plan. So that's why, so your main memory also contains the data, but you are modifying the word number 1, right? Let me put star. This is your word number 1 which you are referring, but that is not modified here because you are accessing in the cache. That will occur. So what, sir? I never touch main memory. Always I take the data from secondary memory. Sorry, cache. No. Sometimes what happens? So there is a second memory called secondary memory, and there is a concept called direct memory access. So through direct memory access, sometimes what can happen is this data might be read by this secondary memory. That means we transfer this block here, hence W1 also might be transferred, then disk contains inconsistent data. Remember one thing, so consistency is very important. Whenever you are repeating the data, everywhere we should show the same data, correct? So that's why. So what to do then? So for that is the issue. I'm not saying that that's why immediately I should write. Okay. One alternative is, so whatever I'm going to talk about is write through procedure. Finally, you understood the problem. Whenever we write in the cache, okay, whenever we update, if it is present in that word is present in cache, we update that word. But you get inconsistency. I'm not saying that that's why we have to immediately write it, but I'm just explaining you that this is a possibility. Then the write through procedure is a procedure. What that write through procedure will do is it will update in the cache the appropriate word, and the same word will be updated here also. Understand? That is called write through procedure. Let me repeat. Whenever you are writing one word, that means whenever you want to modify a word which is specified by your main memory address, then go to the cache and search for this word. Let's say you got it. That is called cache hit. When the cache hits, then you get the word and go to that word and modify it. This is the word, let's say. Then immediately you go to the main memory, because we have a main memory address, right? For us, going to main memory is quite obvious, easy, right? So, but it takes lot of time. That's the problem. Then go to main memory and go to the appropriate word. We have address of that. Simply go there and update it. That is write through procedure, very easy. But you see the complexity. So for every write, you have to visit main memory. What is our primary goal of cache memory systems? To reduce the access time, right? So it takes 100, generally the typical values will be like this. If cache takes 1 nanosecond, main memory takes 100 times, 100 nanosecond. Then you are wasting 100 nanosecond for writings, correct? So every write takes lot of time. Then you don't get benefit of cache, right? Then why to maintain another copy, right? Directly you maintain main memory rather than cache, then we will be happy, correct? So that's why. So generally write through procedure is not used. We have an alternative procedure, that is write back. Okay, before discussing write back, we will see an optimization in write through. So with write through, with a concept called write buffer is better than simple write through procedure. So we understood the problem with write through, correct? But you get a consistency, right? If you follow write through procedure, then data will be at a time available in the cache and main memory. Now if you use write buffer, I will explain what is write buffer. If you use it, then definitely you are going to do better than this simple plain write through procedure. Okay, we will see that write buffer procedure. Okay, what is write buffer is, this is just simply buffer, like I can say just set of registers. Okay, so it stores data. So this buffer is going to hold some words, whatever you give, okay, along with the memory addresses. So that is enough to understand what this write buffer contains. Write buffer can hold some of the words which are given by processor. That means processor is referring a word, right? Processor wants to modify some word, right? You have data. That data to be modified, that word, I say that is a word. Okay, example, let's say you are modifying here this word, right? Then the buffer will hold that word. Understand? So that is called write buffer. Then how we use this write buffer, I will explain. Okay. So now in write through procedure, what are we going to do? You have main memory address, right? And data. This is your main memory address, and you have data to write in the memory, right? So because of this main memory address, we realize that is this word's address. Then I will come to cache block, appropriate cache block, using the strategies already from now onwards I don't bother about it. Somehow I will come to the right word and I modify it, I write here. Okay, so new data I have already. Did you remember store instruction? Whenever we execute store instruction, then store instruction has data and memory address, correct? So we'll come to this memory address. and we write the data. So finally that corresponding word is modified, right? Example, see the main memory. In the main memory you have a memory address 100 and already it is containing 20. Then store instruction can update it to 30, right? Correct? That is what happens here also. So there is a word here called 20 that is modified to 30 because of the store instruction, right? Then now see, let me show like this. This is the word called integer something 20. In main memory also we have that word, right? That is 20. Now because of store instruction, since let's say assume that a cache hit occurs, then 20 we will be updating it to 30. Then what we do is in the write buffer we will remember the address. Okay, so don't worry about details, it depends on the implementation. Assume that let's say we have memory address, at the same time the data, okay, we hold in a buffer called write buffer. Okay, and we don't update in the main memory, we simply update in the cache. Okay, 20 will make as 30, but we don't update in the main memory, but we only update in the write buffer. But write buffer is very near to your processor. It is not like main memory, which is after all like a CPU register. It takes very less time to access. That means parallelly I can access cache and this write buffer, and I write 30 here. At the same time I can hold it in the write buffer, right? So that there is no extra effort. Understand? Sir, why are you doing that? I will tell you. Then after that your processor will continue doing the next instruction. Okay, now it means what? Assume that let's say this data is updated, that means store instruction is completely executed. Only thing is we did not update in the main memory, right? So instead of that we write in the write buffer, then your processor will continue with the next instruction in the pipeline. Okay, now so what happens is there will be extra hardware. What that hardware will do is always that hardware will take the data from write buffer and address, and later whenever it gets time it will update that into main memory, not immediately. Understand? So that parallelly things can work. Understand? Now we'll see one example clearly. One hypothetical situation is you have a store instruction and lot of add instructions, add, subtract, multiplication and everything. So the beauty of this set of instructions is only the store requires memory access, correct? All these instructions doesn't require memory access. Then what is going to happen is, let's say you are executing, assume that again pipelining. In the first clock cycle you are executing cycle store instruction. In the second cycle let's say add instruction. In the third cycle, so in between, before that there are a lot of instructions. We know that in pipeline for every cycle we can execute a new instruction, right? So third cycle, fourth cycle, in that way. Now you see we are at now store instruction last stage. What is last stage? Updating the data in the main memory. For that we use cache, correct? So within one cycle we will come to the cache and we write that 30, and in the same cycle we write in the buffer also, right? 30, and we go. Then we execute add instruction, everything, we continue. Since all these instructions never require memory, then your memory is free, correct? Now your main memory I can say free. Now in these cycles, when your processor is executing addition, subtraction, multiplication, so no one requires this main memory, then happily if you design a small circuit which can independently write the data in the appropriate memory locations, so that we can save the time. That is about write buffer, right? So write buffer plus write through combination will can do lot of wonders, right? So this is about write through procedure. Now we will see an alternative. If there is no write buffer, then it will be very difficult. But sometimes what happens, you see, sir, what if this instruction is load? And what if you have another store? Maybe otherwise there is an instruction called add which does not require memory, but add wants to use data. Let's say add wants to use data, and that data, let's say, is coming from this one, from main memory. That means before you update it into the main memory, what some of the instructions wants it, maybe not directly add instruction, let's say load instruction. Load instruction wants to load the data from main memory, but unfortunately that load instruction wants to take the data from here. Then inconsistency will arise, right? Then sir, how you do things? Then remember one thing. So there will be, that's why we have to design a complicated hardware. That's why I just teach you the idea. I don't show the circuit. Okay, don't worry about the circuit. So what happens is there will be an extra circuit. What it will do is, whenever there is a new instruction getting executed, that instruction's memory access, that means that instruction has a memory access, then only we have a problem, correct? If someone touch, this is 20 now, if someone wants to access main memory, and especially this one, I have a problem because I have not updated it, right? Then what I will do, before that itself I will update. But however, data is available here, right? I mean, if they go to cache, no problem, correct? If they come to cache, then I give my data. Even write buffer says, my dear other instructions, anybody wants to take the data from here main memory, first of all come to cache. We have data in cache, correct? If you don't get it, then before going here we ensure that we update here. That's why it's always possible, it's not a big deal. So these details are I can say not very important, but you understand them finally, how the things works in the real processors. But what is important, I will tell you for gate. Okay, because in gate we have lot of subjects, every point we cannot remember. Don't try to remember every point, but just go through them. You remember whatever you can, that's enough. Now important points about write through procedure is, finally, if you have only write through procedure without write buffer, then we write the data into cache. Okay, if there is a cache hit, then immediately we will write in the main memory. If it is write through plus write buffer combination, then what we do is we write only in the cache, and temporarily we keep the data in the write buffer, and after that your processor will continue with the next instructions, and in the next cycles, if no one requires memory, then this write buffer will write the data into main memory eventually. By that time, before that itself, if you want the data, however it's already there in the cache, there will not be any problem. We will give that even from write buffer we can give. Understand? So that's why effectively write buffer is going to save our lot of time. Remember it. Now there is so far we have assumed that there is a write hit, right? What if there is a miss? Now we will discuss about write through procedure. Write through is not completed. Okay. So we have write through procedure, but there is a miss. What are we going to do? We'll see. This is your cache. This is your main memory. Okay. This is a particular. So now since it's a miss, so data is not available. So this is the word which you are referring. Okay. So this is your corresponding block. In this block, we are referring this word now, but there is a miss. We didn't get. What to do then? Generally, we have to bring this entire block into the cache, correct? So in write through procedure also same thing we do. What we do is, one simple solution is write all this data here first. Entire block will be moved because cache miss, right? Then all this block will be moved here. Then after that, the appropriate word will be updated. Okay. But sir, what about in main memory? In main memory also we do it. Then we update here also. Understand? Otherwise, first go to the main memory and update there wherever you want, because you did not get the data in cache. Then after that, this entire block will be transferred here. That is about miss. Understand? Now here also we can use write buffer. Okay, how write buffer helps here? Example, you have a write buffer. What you do is, you did not get in the cache, right? Then now this is the time to first of all move the cache block, right? So simply move right. Okay, move the data. Now we have to write it, right? Then write here. After that, tell to the write buffer, my dear buffer, I am going to give you one data and memory address. Whenever you get time, whenever this memory is free, whenever no processor is using, then go there and update. That is about miss. Understand? So let me summarize finally about miss. So whenever there is a miss, there are two strategies. One strategy is without write buffer. When there is no write buffer, simply take the data. First of all, update in the main memory and transfer all the data to cache. Now cache also contains the data, write data, right? That's it. So that is about miss. Now second thing, what you do is first transfer the data from main memory. Okay, transfer the data from main memory. Then update in the cache, in the right place, update it. Then same data you write in buffer, but don't update in the main memory. Why? This buffer is going to update that later in the other clock cycles. Understand? So this is about write through procedure. Understand?